Hello? Hello?
Hello. Yeah. So shall we start?
Yeah. Yes,
Okay.
sir.
Good evening, everyone. Myself, Dr. Arun, scientist from CMET Thrissur. It is a great privilege for me to connect with all of you to have a small introduction about today's event. So we all very much aware about CMET activities. Especially, we have 3 centers across India. So we have our headquarters in CMET Pune, and the labs at CMET Thrissur and Hyderabad are also there. And each centers are having a kind of its own vision and mission to develop materials for various electronics applications. And also, we comes under the Ministry of Electronics and IT. And as there are a lot of dignitaries from various parts of country, it is a kind of a privilege for me to introduce about the institutes. So CMET Thrissur and Pune jointly organizing this particular talk for 2 reasons. One is that, as you all aware, our ministry is kind of very much pretty sure to maintain the cleanliness in a work area via the Clean India and Swachh Bharat mission. So as part of that, we as a CMET people wanted to create the awareness among our community and as well as scientific community to create awareness on RoHS facilities and kind of a restriction of hazardous wastes. And as part of that initiative, we are having today very legendary speaker among with us. He's a kind of a man who had all the kind of facilities set up at a lab called RoHS facilities at CMET Hyderabad, and he's one of the active member and scientific manpower who is holding all the facilities, and he will be introducing most of the facilities today to us on the restriction of hazardous waste. And this event is also part of a creation of R&D culture in electronics materials among SC/ST students. Is a funded project by our ministry at CMET Pune. So on behalf of all the organizing committee of CMET Pune and CMET Thrissur, I am welcoming all of you, and I hope today it will be a great day for you to know about one of the nation's greatest facility on RoHS. And I welcome, and also I welcome CMET committee to introduce the speaker of today. Thank you so much.
Thank you, sir. Good evening, everyone. I am Rhs Kale, projection of first under the mighty government of India sponsored project, creation of R&D culture in electronics materials among SC/ST students in Maharashtra. On the behalf of CMET Pune, I welcome all of you here for today's lecture. Today we have speaker Dr. Ram Babu, senior scientist from CMET Hyderabad. Dr. Ram Babu completed his MSc and PhD from the SV University, Tirupati, Andhra Pradesh. His area of research are high purity metals, extraction of rare earths from waste, phosphorus and permanent magnets, RoHS testings, MOS grade acids and solvents, inorganic luminescent materials for solid state lighting and WLED applications, phase changes, optical discs, amorphous magnetic materials for his memory storage application. He has completed many major projects of budgets more than 9 crores, and there are few ongoing projects to his credit. His scientific contribution has been recognized and published in highly reputed international journals. He is also a recipient of highly prestigious awards and honors on his name, namely Upalpati Abjahan Award for securing first ranking applied spectroscopy MSc, and also Dr. M.R. Bide Award, Department of Physics, University of Pune in 1998. His fellow of MRSI Best Poster Award for the years 2007 and 8. He is also visiting scientist fellow National Chauteng University, Taiwan in 2022. He is also Boycott Fellow sponsored by DST in 2011 and Red Bull Fellow sponsored by South Korea in 2011. He is also a member of many scientific bodies in India and abroad. I welcome here Dr. Ram Babu to deliver his talk. Sir, please.
Sir, share your screen, sir. Hello?
Hello.
I am sharing.
Yes, sir.
It is visible?
Yes, sir. Yes, sir.
First of all, thank you very much for the organizers. Unfortunately, yesterday I got COVID positive, but however, we announced the dates. That's why I don't want to stop it. So first of all, thank you very much for the organizers. So initially, CMET Pune people requested me for give a lecture for this SCST projects. So I would like to inform to you all that I am also having SCST projects from MIT on eBay, that is skill development program on e-waste dismantling, segregation, and testing of restricted hazardous substances. So it's an ongoing project. So we have completed 1 year. So still by 2023 July, they are going to complete. So I will start my work. I would like to thank the directors of CMET Pune, Dr. Kale sir, and director of Trishur, Dr. Raghu sir, and our director, Dr. Ratish sir, for giving this opportunity to introduce our facilities to the students community of SCST community of Maharashtra. So the topic of today my lecture is on overview of CMET's in-house restriction of hazardous substances. So in short form, they called RoHS testing facilities. So actually we started this project in 2007. So it was funded by MIT. So we completed this project in 2 phases, that is phase 1 and phase 2. So now this facility is running on self-sustainable mode. It means we are charging some 3,000 rupees per metal sample and 4,000 rupees plus GST for plastic samples. So it is we are so far we have earned 1.5 crore. So we are separately creating one fund for this. So whatever revenue we are generating, so we are maintaining all this equipment from that fund, and so this facility is running with the services of the permanent staff only. So when that project was there, we hired some 5 project staff. Now we are running with the existing core manpower. So that is the introduction about this project. So coming to this, actually this is comes under waste. So there are coming to the classification of waste. So we have 2 types of waste, that is biodegradable waste and non-biodegradable waste. So in biodegradable waste, it is mainly having organic matter and can be degraded. It means it will be decomposed after a few days. So we know what are those things like paper, food waste, vegetable, fruit peels, wood, etc. And this non-biodegradable waste is nothing but inorganic and recyclable materials like plastic, glass, and metals. So these things are not going to decompose or degrade after so many years also. So whatever we are talking, this electronic waste comes under this non-biodegradable waste. So coming to major types of solid waste. So these are the major types of solid waste, that is municipal waste, hazardous waste, biomedical waste, and electronic waste. So this RoHS comes under electronic waste. So coming to these e-waste management rules, these are the definitions, exact definitions of e-waste and electronic and electrical equipment. That is also called EEE, WEEE. W triple means waste electrical and electronic equipment. So e-waste means it's a waste electrical and electronic equipment in whole or in part, so which rejects from their manufacturing and repair process, so which are intended to be discarded. We know that suppose our mobile phone is there, that screen has got broken, so we will go to the service person. He will tell that, sir, why you are going to replace this screen? If you put that same amount and some extra amount, you will get some new piece. So then we will discard that. So that type of things, so accumulated, it will become like a waste in every house. So coming to this electronic waste, so wherever we, that is a equipment, wherever we use this electrical current or electromagnetic fields, so which functions based on this, so that device is called EEE, that is electrical electronic equipment. So what is RoHS directive? So RoHS stands, as I told, Restriction of Hazardous Substances. That refers. So this was initially started by European Union countries in 2006. So in different countries, it is called by different names. Like in China, it is called EIP, Measures for the Administration on the Control of Pollution in Electronic Information Products. In Japan, it is called JMOS. In Korea, it is called Act on Recycling of Electrical and Electronic Equipment and Vehicles. So in USA also, it is already implemented. So why RoHS is required means, so electrical and electronic waste is usually dumped in landfills. So when we dump this electronic waste, what happens? Over the time, hazardous substances in this waste seep into surrounding land and waterways and eventually into the seas. So leading to dangerously high toxic substances in the food and water we consume. So this is the main objective, to take care of our environment and the quality of air, water quality, soil. So to minimize this contamination, they started this directive. So here you can see how these people are doing landfilling all this electronic waste. So they simply, whatever this discarded electrical cables, they will burn and throw that ash. So that ash contains a lot of lead, mercury, and they will simply take that copper. So these hazardous substances like mercury, cadmium, and all going and landfilling, and they may go into the water. So whenever these farmers are using this contaminated water, so it will be transferred to our food items. So even the fish is also affected with mercury. In other slides, I will tell in detail. So it is finally showing adverse health effects on our generation and our future generations also. So to take care of that, this RoHS directive was started. So these are the restricted hazardous substances. So actually this RoHS is started, when they started, they called RoHS 1. So this RoHS 2, RoHS 3. Now RoHS 3 is going on. So in RoHS 2, so these are the identified restricted hazardous substances like cadmium, lead, mercury, hexavalent chromium, polybrominated biphenyls, polybrominated diphenyl ethers. So these are the 6 hazardous substances. So when we talk about RoHS 3, so they have added some more phthalates. So they are like bis 2-ethyl hexyl phthalate, butyl benzyl phthalate, dibutyl phthalate, diisobutyl phthalate. So these are called phthalates. So where they are going to use? So they are going to add to the plastic to increase the transparency, flexibility, and durability, longevity of plastics. So they simply adding these phthalates. So now one can ask, what is the limit? So we know all where lead is used, though it is used in solders, termination coatings, paints, pigments, PVC stabilizers. So they are majorly used in lead acid batteries. Cadmium is having applications in coatings, semiconductor contacts, PVC stabilizer, pigments. So everybody knows where mercury we are using. That is used in fluorescent lamps. So sensor relay manufacturing. Hexavalent chromium, that is nothing but it is used for metal surfacing coatings to take care of corrosion. And PBB, PBDE, they are also called brominated flame retardants. So they are polybrominated biphenyls and polybrominated diphenyl ethers. So here you can see the limit of maximum concentration value allowed. If we take any individual or all together, it should not be more than 0.1%. 0.1%, if you convert in ppm, that is 1000 ppm. If you see cadmium, it is further decreased to 0.01, means 100 ppm. So if you take any electronic component, you should not use more than 100 ppm of cadmium. So these are some of the figures of this section 1 talks about the list of items comes under this RoHS guidelines. So these are nothing but large household appliances, small household appliances, IT and telecommunication equipment, lighting equipment, electrical electronic tools. So there is one list of exemptions also, because so far we have not found any alternative materials for these substances which we are using. So for that type of items, they have given exemptions. So this is the list of exemptions you can see in schedule 2 of RoHS regulation rules. They are like military security equipment, space equipment, means of transport like cars, commercial vehicle, aircrafts, large scale fixed installations, non-road mobile machinery, photovoltaic panels, because we require power. So we cannot restrict this photovoltaic panels, because in photovoltaic panels, everybody knows we are using cadmium. So cadmium is restricted, but it comes under exempted list. R&D equipment like balances, this medical devices also. So here you can see the pictures. So all this medical equipment comes under exemption list, medical equipment, and this type of measurement control equipment like this calibration standards which we are using for calibrating these balances. So these are all comes under exempted list. So one can ask, whom does RoHS will affect? So these are the people for whom this RoHS will applicable, like original equipment manufacturers, component makers, subcontractors, assemblers, distributors, exporters, traders. So this RoHS directive is applicable to all these people, whoever deals this. So as this is the e-waste handling rule 2018, as I told, it is having like 6 chapters and 3 schedules. So chapter 5 talks about RoHS. So these are the objectives of e-waste rules, like to minimize illegal recycling, recovery operations, environmentally safe sound recycling by channelizing e-waste to registered. So informal, actually so far this e-waste is going to informal sector. So by implementing these e-waste management rules, so we should have some this accountability. So where, how much is generated e-waste and where it is going. So all this can be restricted by this e-waste management rules, and they are giving some extended responsibilities to producers. So means once whatever they are manufacturing, once it comes to their end of life, so how they are going to deal. So whether they are going to buy back. So all these things are explained in extended responsibility of producers. And so the responsibilities to urban local bodies for orphan products and for waste found mixed with municipal solid waste. So to create the e-waste channelization system and to reduce the hazardous substances in EEE products. So whatever e-waste generate in future, so if we implement this RoHS, so the amount of hazardous substances will be less, because since their manufacturing we are restricting. So finally it becomes waste also. So we are able to reduce the waste. So these are the main objectives of this e-waste management rules. So coming to the toxicity, so toxicity is two types, like physical hazardous and health hazardous. So coming to this health hazardous, these are all comes under health hazardous, like toxic, corrosive, or irritating, carcinogenic. Carcinogenic is nothing but which causes cancer. Reproductive system. Nowadays, most of the youngsters are having reproductive irregularities. So all these things comes with under health hazards and sensitization. So actually have an effect on one or more body organs. So once it enters our body, so it is going to affect multi organs, and these effects may be varied. So it may damage the lungs, stimulate or depress the nervous system, or damage other systems such as kidneys, liver. So I am going to show. So here what they are saying, that it will enter with one organ and it is going to target so particular other organs in the body. Suppose it may be being inhaled into the lungs, but it is going to affect the liver. So these are the toxic chemical effects. So coming to this lead toxicity, so these are the possibilities how the human beings are going to expose to this lead contamination, like some pesticides, through paints. So whenever in olden days people are removing the old paint, so whenever this labor is exposed to the dust, so that is one of the way for exposure, the dust. So that will be going into the system, like whenever you consume this lead having foods, sediments, soil, water, whatever water we drink contaminated with lead, as I told, dust, petrol, industry, mining and all. So these are some of the examples for exposure of lead. So once it enters our body, here you can see the lead is going to be 95% of lead is going to be in long bones. 4% it is deposited in soft tissues, especially brain, liver, kidneys, and 1% of this lead will be deposited in blood. So once it, so these are the neurological effects with the lead poisoning, like neurological effects on children documented at levels below 10 mcc for DL. Low exposure effects, lowering it will lower the IQ, attention deficiency in the children. So these are the neurological effects of lead. So cadmium mainly comes through the food items, and these are the health effects like diarrhea, bone fracture, reproductive failure, possibly even infertility will take place, damage the nervous system, it will damage immune system, psychological disorders will take place, and possibly DNA damage, and it will develop the cancer also. So here I have given one small example how this cadmium is entering into our human body. Suppose this is the zinc mining company. It is discharging some waste water. So this waste water, whenever this nearby farmers are using, so it will from through water, from soil, through roots. Finally, it is reaching the rice. So whoever eat this type of rice, what happens? No. So this will replace calcium in our bones, and it will also accumulate in liver, kidneys. So liver, kidney cancer may take place, and this type of bone diseases will come through this cadmium poisoning. So coming to this mercury, so mercury mostly they are used in thermometers and fluorescent lamps. So when we are not properly handling this end of life fluorescent lamps, so what we normally do, we will just throw in the municipal this dustbins. So while transporting it, if it breaks, so that mercury is going into landfilling. So here you can see, due to this chemical reaction like leaching, volatilization, deposition, oxidation, reduction, so finally it will be converted into methyl mercury. So methyl mercury, when it deposited in sea or water ponds, so the small fish finds it as a what is that sweetie food. So whenever this small fish is eaten by this bigger fish, so like that, so as the fish size is changing, there is a possibility of accumulating more mercury. So this is how whenever we consume this type of fish, so it is entering in our body. So that is one of the example how this mercury is exposed to, we are exposing to mercury. So that's why these pregnant ladies are strongly suggested don't to go for this type of meat and fish consumption, because from mother womb to baby, this mercury contamination will easily transfers. So even in advanced countries like California and all, you can see they developed very fast, and all these water resources got contaminated. Here you can see the public warning: the fish, frogs, and soil in this area contain mercury and other toxic chemicals. Do not eat the fish. So that is the situation in the advanced countries. So these are the diseases comes with the lead poisoning, like anemia, limb paralysis, headache, colic seizure, anorexia. So these are the diseases comes with the lung edema, mercury poisoning, irritation of skin. So you can see clearly how the skin is getting ulcers. This itai disease will come. Here you can see this is the healthy kidney, and after disorders affected with mercury contamination, so how it is spoiled. So these are the diseases comes with cadmium toxic. So here you can see clearly how this this cadmium is going and deposited in lung, these cross sections. So these are the diseases comes with chromium, hexavalent chromium, like lung cancer, skin ulcers, mucosal ulcer, bronchial effect, and all. So these are the skin ulcers. So the major disease comes with PBB, PBDE, phthalates poisoning is nothing but thyroxine disturbance. It will target thyroid gland. So you can see clearly before this poisoning and after poisoning how his face got changed. So these are the health effects. So these are about phthalates. So phthalates normally they are used in color cosmetics, fragrance lotions, body washes, hair care products, nail polish, and treatment. So these are the health effects of phthalates, like endocrine destruction, developmental and reproductive toxicity, organ system toxicity, bioaccumulation. So so these are also used in cosmetics like nail polish, nail polish and lipsticks and all. So whenever you, especially ladies buying this type of cosmetic, they should see whether they are phthalate free or not. So otherwise, whenever we are consuming food every day, some ppm levels of these phthalates will go inside. So after a few years, so one can get this type of diseases. So these are some of the examples where we are using these phthalates, like water bottles, all these toys, these textiles like raincoats and all. So here you can see how this kid is chewing these toys. So these toys are having, because for different colors they are using the pigments like lead based, cadmium based, phthalate based. So we should be very careful when we are using this lipstick, nail polishes and all. So we should, even though they are expensive, we should go for RoHS compliant products. So so people, hexavalent chromium, why we are using, they are used in pigments, catalysis, plating and tanning, parts with a metal frame. So they are used for screws, nuts, some parts to take care corrosion. Actually, coming to this hexavalent chromium, it is available in two valencies, that is chromium 3+ and chromium 6+. So chromium 3+ is used, it is required for humans, which will control the glucose levels in blood. But hexavalent chromium is very dangerous. It is carcinogenic. It will cause cancer. So here I have given some advantages why we are using hexavalent chromium. So these are the diseases comes with hexavalent chromium contamination. So here we can see by seeing the surface, we can say whether it is hexavalent chromium coated or not. So if you find this nut and bolts with this color, so definitely they are coated with hexavalent chromium. So nowadays people are looking for the alternatives. So these are the alternatives for lead, like electroplated tin, electroless nickel immersion gold. But these are all very expensive. These are the alternative materials for cadmium, like zinc based, zinc nickel, zinc cobalt. But cobalt is also expensive. And for mercury, people are trying some sodium vapor lamps, sulfur lamps. So, but whatever these lamps emits that light, so that clarity is not like our CFLs or white LEDs. So these are the disadvantages. So there is, so far we have not found any alternative for mercury. For PBB, PBDE, these are the suggested alternative materials like tetrabromo bisphenol, non-halogenated flame retardants like aluminum hydroxide, magnesium oxyhydrates and all. So these are some of the examples where we are using cadmium. So all these photovoltaic panels, nickel cadmium batteries, alloys, ICs. So coming to this mercury, mercury is very dangerous. So generally we found mercury in this temperature measuring thermometers. So very small amount of mercury can do a significant damage. So 1 gram of mercury per annum is going to contaminate all the fish of 8 hectares. So normally what happens, no, this in CFL bulbs, we are using mercury. So actually what happens, if you use more mercury, the lifetime of the lamp will be more. So if you use less mercury, the lifetime is less. That's why if you go for some unbranded this lamps, not other than Philips, Havels, because we have tested so many CFL bulbs at our laboratory. So actually, as per their wattage, we can go from 5 milligrams to 40 milligram level. So these are the CFLs, fluorescent lamps. They are using the mercury. Coming to the main part of our topic, so the facilities which we established at CMET Hyderabad. So I am going to talk about that. So actually, we are following this IEC 62321 procedures. So IEC is nothing but International Electrotechnical Committee. So actually, some few countries sat together and they formulated these procedures. So whoever doing this RoHS testing, they should follow these procedures. So we are also following these procedures. So this is the laboratory separate building we have constructed for RoHS. So inside you can see our facilities. So this is like a world-class facility, and each equipment is housed in separate rooms, so to avoid the cross contamination. So this is the wet lab, so where we are processing all the samples. So this is ICP-MS room, this is a GCMS room. The important thing here, once the sample comes, we have to adopt this process flow sheet. Suppose if the customer don't know about his product, whether it is RoHS compliant or not, if we don't know, and then we have to go for this screening. So for screening, we are using Edx Rf. It is nothing but energy dispersive X-ray fluorescence. So in Edx Rf, so if we found bromine, actually in Edx Rf, what it will give? It will tell about lead, cadmium, mercury, bromine, and bromine mean PPB, PBDE, it won't say, it will give total chromium. And in the case of chromium, it will tell the bulk chromium, not the valency of chromium. So here, if the bromine is more than 0.05%, then there is a chance for PBB, PBDE. And one more thumb rule is, suppose with bromine, we are getting antimony. It is used as a sensitizer for brominated flame retardants. Bromine and antimony is coming together, then there is a possibility for PBB and PBDE. So then we have to go for GCMS analysis to find out whether it is in the PBB form or PBDE form. So that is for brominated flame retardants. So for phthalates, there is no way. So we have to simply go for GCMS. Suppose this lead, cadmium, mercury, if they are in borderline, suppose 1000 ppm is the maximum concentration. So if by Edx Rf we are finding that 800 ppm or 700 to 800 ppm, then we have to go for accurate techniques, because Edx Rf resolution is not good. It is only a screening technique. You know what is screening? Screening means nothing but a pass-fail analysis. So whether it is passed or failed, if it is below 800 ppm, we can say the product is passed. So more than that, then we have to go for detailed analysis. For a detailed analysis of lead, cadmium, mercury, we have to go for IC2OES. Coming to this chromium, so chromium, it will shows more than 800 ppm. Then we have to see whether it is in chromium 3+ form or chromium 6+ form. So for this, there are different sample leaching methods. So boiled water technique is there, alkaline leaching method is there. So I will cover in the next slides. So for that testing of this hexavalent chromium, we have to go for IC, ion chromatography technique, or UV visible technique. This is about the testing procedure for RoHS. So these are the techniques for testing different substances. Like if you want to test lead, Edx Rf screening technique, and ICP-MS, ICP-OES, even AAS also we can use. Cadmium screening, Edx Rf, and ICP-MS, ICP-OES. For mercury, cold vapor technique is best technique. Otherwise, you can use ICP-OES. In ICP-OES, that memory effect will come. So that's why people are strongly suggesting cold vapor AAS. Coming to this hexavalent chromium, as I told, IC and UV visible. Hello. Sorry. So polybrominated biphenyls, we have to use the GCMS technique, and polybrominated diphenyl ethers and phthalates also we have to follow GCMS technique. So in RoHS, testing, so the major drawback is the homogeneity of the sample. Homogeneous material means where we are not going to disjoint the sample mechanically. Suppose this is the sample, so it is nothing but a steel sample, and that it is coated with the zinc. On top of this, it is coated with the hexavalent chromium. Suppose if you give this same sample to 2-3 analysts, so if somebody did Edx Rf from here, it will give the composition of steel. Somebody analyzes, if you keep the sample like this from the top, exposed to X-rays, so it will give the composition of hexavalent chromium. So it means everybody will give wrong reports. So that's why this is a major problem in RoHS testing. So we have to take the homogeneous sample. If the sample is not homogeneous, we have to make it homogeneous. Suppose if this type of samples are coming, then we have to test this part separately, and we have to, by abrasion, we have to remove this layer and test that separately. So that is the methodology. So if you see different electronic components, you can find out the possibilities of different hazardous substances. Suppose this is CRT monitor, so this is having lead and cadmium. some plastic is there. In plastic, lead cadmium is there. So like that, by seeing, we can get some ideas. So these are some of the examples where we can find lead. So these are the examples for PBB, PBDE. So as I told, by seeing the color itself, we can say whether it is hexavalent chromium coated or not. So suppose if this PCB has come for Rhs analysis, so how to do the Rhs analysis? So first we have to make homogeneous samples. So we have to segregate like ICs, resistors, capacitors and all. We have to mechanically design even those components also. We have to separate the metal and plastic. Then only we have to test. If this type of homogeneous samples are coming, so we have to simply take some 0.3 to 3 grams, make it homogeneous and go for leaching and all. So one more major issue in sample dissolution is, so most of the samples won't dissolve at no, normally we are dissolving using hot plate, no, at normal atmosphere. But some plastic, ceramic type of samples won't dissolve on hot plate. So we have to go for a microwave digestion system. So these are the advantages of microwave digestion system. Like here, suppose some we are going to test mercury, arsenic, selenium, antimony. So they are they are volatile. So if you dissolve in a hot plate, they may evaporate. So we are going to lose these substances, and we are going to get wrong reports, wrong results, and minimum contamination. So if you use this is a closed technique, so there won't be any contamination. And by using MDS, we can get complete digestion of the sample, and accurate reaction control will be taken place in microwave digestion. Economic benefits. Suppose if you want to analyze some 25-50 samples, we have to deploy more manpower, but at a time we can dissolve some 50 to 20 to 50 sample using this microwave digestion. And a minimum consumption of reagents like acids here we can use. But if you do on hot plate, whenever that acid is operating again, we have to pour. So like that, there will be more consumption of acids. And this is also very fast technique, and it is very safe and easy handling. And here earlier, suppose some analyst, he worked for 5 years, he got a lot of knowledge. Suppose if that fellow is leaving our organization, so it is the other fellow, whoever joins, is not finding array, this will dissolve in which acids, what are the conditions we have to maintain. So those problems will be nullified using this micro digestion, because here it is having the preloaded library. Suppose some plastic PVC is there, PE is there. So what methods we have to adopt, what is the acids and what is the volume of acids we have to take, what is the temperature, pressure we have to manage. All this data is available in methods, and wide range of compactable accessories. So here there are some the consumables also. We have to use that Teflon, ceramic jackets and all. So finally, for dissolving plastic type of samples, microwave digestion is compulsorily it is recommended. So suppose this type of PCB is there. Initially we have to make into powder. Then using this microwave digestion system, so we will get this clear solution. So this clear solution we are going to feed to ICP-OS and other techniques, whichever you are looking for. So coming to this screening, as I told, this is a non-destructive fast analysis. Here in Edx Rf, we are not going to cut the sample or dissolve it in acid. So as such, if we keep in the sample compartment, it will give the composition. It is very fast. But the limitation is it needs reference materials, because for ICP-OS we can make our laboratory made standards also, but here in Edx Rf it is not that much easy, because these are all solid samples, solid standards. So the homogeneity is a problem. So we cannot make at our laboratory. So we have to buy from the like MAT, some authorized company, NIST traceable companies are there. From those people only we have to buy the standards. So, and we have to follow the calibration also here. Coming to this wet chemistry, for if you want to dissolve, make the samples for ICP, OES, MS, CVAS, AAS. So we have to distract the sample. We have to digest in acids. So it is a time-consuming process, but more precision will be there. Here also we have to use calibration of the standards. So as I told, so this is non-destructive testing. This is destructive testing. So after analysis also, this dollar looks like this only, but in some analysis like GDOS and all, after analysis, it will be decomposed, deformed like this. So this is the difference between non-destructive and destructive analysis. So this Edx Rf is a non-destructive analysis. So here we are going to test cadmium, lead, mercury, total chromium. As I told, bromine is going to test as a total bromine, which will represent PBB and PBDE. So it is rapid, direct, and non-destructive test. As I told, it is very hard to get standards. If you have the standards, the detection limits are good in Edx Rf. So this is the Edx Rf machine we have at CMET Hyderabad. So this is from Thermomake. It is called ARL Quantex. So here you can see, suppose I want to test this EEE products like a plug. So this plug is having a plastic part here. Here one cable is there. These are the pins. So you can analyze using this Edx Rf. So this metal part is having calcium, copper, zinc. This cable composition is this. Suppose this is another cable. So this part is having nickel, copper. So if you see this plastic, it is having lead. So these are the lead peaks, and this cable is having antimony. So like this, we can test non-destructively using Edx Rf for RoHS. So Edx Rf is also having some other advantages. So this machine we can use for point analysis and mapping analysis. Suppose if you want to test, you want to see the composition of this point and this point. So here you can see that is called a spot test. And you can suppose whatever this red area you are seeing, that is nothing but lead. So if you want to see the lead, it will map with different colors. So all this red color indicates this soldering. So like that, we can use this Edx Rf machine for mapping facility and spot analysis also. So our laboratory is giving whole product certificate also like this. And these are the some of the examples of fluorescent lamps we tested at our laboratory. So our laboratory is also what is that BAS recognized for testing mercury. So whatever CFL bulbs we are manufacturing in India, so almost all the bulbs we have tested at our laboratory. So mainly they are coming for mercury and rust. Earlier they used to come for mercury. Nowadays they are coming for rust also. So coming to this disassembly. So most of the people, they think that if they are sending one product like charging, what is that, cell phone charger, they are thinking that we are going to give one certificate. It is not like that. So suppose this is a printed circuit board. So if you want to have this RoHS compliance certificate, so we have to remove all these parts and test for RoHS. So this is the sample disassembly, like green coating, brown epoxy resin. So all these individual parts we have to test. PCB capacitor, so conducting wire, solder. So these many parts we have to individually dismantle and test. This is a speaker switch. So see how many individual parts it is having. So this many analysis we have to do. This is about capacitor and IC. So it is this is transformer. So this many products, this many individual samples we have to test. So as I told, this is a charger. See how many nearly 26 individual homogeneous samples are there. So 26 samples we have to test. Then only we can give the product certificate for this charger. And we consider 26 samples, and we will charge for 26 samples here. So this is a fluorescent lamp. So this is having this many ports, and these are the mobile phones. So here you can see each and individual, and the possibility of hazardous substances like TFT is having chances of lead, keypad, cadmium, mercury. Bottom housing may have this cadmium, chromium. So like that. So it is further dismantled into this many components. So TFT components of PWD, printed wiring board. So it is having this many components. So this CFL bulb, we have to totally do 21 samples analysis if the company wants RoHS certificate for this CFL bulb. So like that, we had a small project from Cellular Phone Association. So they have given some small 15 lakhs project to test all these gray mobile phones. So actually every year we are going to generate 1350 tons of toxicity from mobile phones. So whenever the new generation phones are coming, we are changing, and that old phones they are becoming like a e-waste. So all these mobile phones we tested, and we identified these are the targeted components for testing as per international norms, like solder, memory slots, mix soldering point, SIM card 1, SIM card 2, and all. So whatever I have shown with the red color, so the limit is 1000 ppm. No, so these are all beyond limit. So we can say these are all failed as per RoHS regulations. So this red color is limit. So you can see the peaks up to 60,000 and all. So these are all China made mobile phones. So China is dumping simply in India. So we tested this electrical cables available in market. So we different brands, different gauge sizes and all. And you can see the lead. So these are the lead peaks from Edx Rf, very prominent peaks. Here you see very intense. So the limit is 1000 ppm, but all these cables are more than 1000 ppm. So we tested with different techniques like Edx Rf, ICPOS. So we published this paper in American Journal of Testing, and this one. Even this carry bags. So carry bags, even whenever we buy some vegetables, chicken, mutton at shops, no, this black color. So we tested this bag. It is having cadmium more than 100 ppm. So see here you can see the peaks, very prominent. This is a Paradise Biryani carry bag. So this whatever red color is there, so this is nothing but lead paint. So simply we are what is that, throwing our garbage. So with sunshade temperature, it will decompose, and all these pigments are going into landfilling and spoiling our soil and water. Even so in Challapalli area, so most of the industries are there, manufacturing industries. So we asked, we have collected so many unbranded paints. So these are the unbranded paints we have tested. You see the lead levels. Actually, it is having 5917 ppm, some black color, and this is blue color, 9032, some green color, 3365. This is some rust color, 3556 ppm. So because I asked the people whoever using, they are telling that the with this RoHS compliant paints, they are able to buy 2-3 times of more volume paints of unbranded. That's why they are using. So that is happening nowadays. So we have, these are the showcase of some of the samples we are getting regularly for RoHS compliance testing. So even this coffee day machine, so coffee day machine also, it came the whole machine, it is called Sienna coffee day machine. So we tested the whole product, and there are some 4 or 5 components failed. So we suggested them to go for alternatives. So they changed. Then we issued RoHS compliance certificate for this. Even this type of mosquito mats available at signal points, they are selling, no, some people. So we also tested. They are also non-RoHS compliant. So our laboratory is NABL accredited laboratory. Once in 2 years, we are going for accreditation. So who are the responsible for this RoHS? So who is responsible? Actually, producers are responsible. So that's why these producers, whatever chemicals they are using, they should test them and keep the data at least for 4 years. So as per once they want to become a RoHS compliant company. So how this will be enforced, this RoHS? So test purchases are made in the market, will be tested for restricted substances, because wherever this RoHS testing is going on, so they have to send their products and they have to test and keep that reports ready. So they have to follow the compliance documents and issue non-compliance notice, ask for actions taken. Suppose some sub dealers are there, so they are supplying all this raw material. If they are understood that this whatever raw material they are supplying, so it is having lead, cadmium, mercury, all this more than 1000 ppm, then they should ask them to change that starting materials. So like that, they have to strictly, if they want to be RoHS compliant, they have to change. So nowadays, even though medical devices have a late start, means they are under exemption list, but however, we have to test all the homogeneous materials whichever we are using, and we have to document the same, and look for alternative materials, process wherever restricted hazardous substances exceed the limit, also wherever EOL is announced, end of life is announced. So people are working on that. So they are looking for alternative materials. So what does RoHS compliant means? RoHS compliant, so whatever products the company is developing or manufacturing, so they have to test for all these 10 substances, as I told: lead, mercury, cadmium, hexavalent chromium, 4 phthalates, PBB, PBDE, and they have to document. And if they are within the limits, so that company is called a RoHS compliant company. So these are the major steps involved, like testing, processing, auditing, documentation review, certification of the statements. So they have to maintain all this if they want to be a RoHS compliant company. About the status, EU and many other countries, including Japan, China, North America, have already implemented strictly RoHS and equivalent directives. So the computer, laptop, mobile phones waste is turning into environmentally unsafe in India, because in India our pollution control people are not strictly implementing. A lot of uncertified cellular mobile phones and China-made toys, plastic utensils are being dumped in our country. So that is the actually miserable thing going on, and no exact or drop-in replacement. People are not able to find the exact replacements for these restricted hazardous substances. The several alternative materials have been recommended for each of the banned materials, but there is not yet much field data available for these new materials. most of the cases, the alternative materials are costly and inferior in performance. So that's why more R&D is needed in the near future. And there has been substantial amount of money spent by industry to be RoHS compliant. So nowadays, earlier people used to use lead for soldering. It was very cheap. Now, as per RoHS compliant, so we don't have to use this lead-based this one solders. We have to use, so like that. The cost is becoming a burden for manufacturers, and in future also, now we are only 10 elements are there, 10 hazardous substances elements are there right now in RoHS 3. In future, they are going to add some more elements. So that time it will become a additional burden for these manufacturers. So in the near future, they are going for lithium, selenium, beryllium. So they are going to add. So that time, so because if they want to test one product, they have to spend in lakhs of rupees. And whenever they change the composition, again, they have to go for RoHS directive. It is a burden for manufacturers. So, but safe for safe recycling of existing e-waste. So in future, whatever e-waste generates, it will reduce that hazardous substances. And actually, our CMET is signed a MOU with CPCB, but they are not strictly implementing, and so far we have not received any samples. They are still in making the norms for random checkup. So that is the situation in India. So this is the last slide of my presentation, that everybody should have the awareness about the RoHS regulations. So here somebody is offering some bread and fish. So you can see the awareness of the people. So somebody is asking whether that fish is tested for mercury, and somebody is asking that whatever bread you are offering, whether it is gluten free. It is nothing but gluten means we used to say that maida, no? So this maida is used in all our bakery items. So whenever we use that, so all these bakery items looks like very they won't get any breaks, very shiny, but they are not good for health. So everybody should have some awareness about RoHS. Thank you very much, and you can ask any questions.
Thank you, sir. Any question from the student? If you have any question, just put that question in chat box. Arul, sir?
Sir, I have only one question. So you mentioned that various countries are following the, hello, am I audible?
Yes, sir. Yes, sir.
Yeah. Various countries are strictly following the RoHS standards.
Yeah.
But in our country, we are not still taking into that much in consideration. So even I also seen that you have tested several products from the market, and you tested, and so most of the products are having the limit above the standard or threshold. So in that case, as a CMET scientist, what we can do, sir? Is there any way to make a move from there to comply or something like that from our side we can do, or it is not possible?
Sir, actually, this is the what is that regular question wherever we give the presentation, people are asking. Sir, actually, CMET is not the what is that regulatory authority. So actually, this RoHS compliance comes under MOEF and CC. You know, MOEF, Minister of Environment, Forest, Climate Change. So this is the job of MOEF, like Central Pollution Control Board, State Pollution Control Board. So they are still they are operating. So actually, what happened now? They should avoid importing all the China mobiles, and so only they have to import RoHS compliant products only. So in several platforms we told the CPCB people, and so they told that they are going to take the actions, and if you and they suggested us, if you are come across this type of products, we have shown no some electrical cables, mobile phones and all. So they told that if you find this type of data, you please send to us, and they are going to put in their website.
So there is a way that we can also say that these are the products or items are having the threshold higher than the threshold limit.
Yes,
right,
yes, yes. Yeah. We are doing that.
Yeah. Okay.
We are publishing papers also.
Yeah. I think in country this is one of the first kind of RoHS facility in India. I think.
Yes,
So
sir.
definitely.
In India, our CMET is the only government of India RoHS testing facility.
Yeah. That itself a great thing. So any other questions, please unmute yourself and ask, please. Provided there is no further question, let me take this opportunity to thank
Dr. Arul.
Yes, sir. Sir, please proceed.
I'm sorry. I'm coming at the last minute.
Yes, okay, sir.
Dr. Ram Babu, thank you so much for such a nice way of presenting the topic. Thank you so much for the information given. I have only one small thing to ask you,
sir.
Because you know that we are involved in this tape casting business.
Sir.
So we also use phthalates frequently for our, it's used as a plasticizer in the tape casting thing.
Sir.
So I think you started mentioning some of the alternate materials one can use.
Sir.
And is there anything for phthalates? Because the benzyl butyl phthalate and various other phthalates we are using it regularly. Okay.
Yes,
glycols, phthalates, these are all the ones plasticizer we are very frequently using.
Sir.
So
actually, this bisphenol A and some other component, it is there in my slide. So
no
they
issue,
are they are suggested as alternative materials, sir.
Fine, sir. But I don't know whether that will serve the purpose as a plasticizer. I don't have the background. But kindly let me know what are the alternatives. I will try and see how best I can.
Definitely, sir.
Definitely. Okay.
Definitely.
Thank you so much. Kindly go ahead.
Thank you, sir. Thank you.
Hello.
Dr. Arul Kashmir, kindly, unless there are other questions.
Hello.
Yeah.
Yes, sir. Yes, sir.
Hello.
Yes, sir.
Thank you, sir, for very good lecture. I have one question. Most of the industries and in market also, plastic bags are replaced by the paper bags.
Yes, sir.
But people are making fancy paper bags and they are coated with the different colors.
Yes, sir.
So that color may be contain lead and other toxic material.
Sir.
So is there any facility that these bags can be tested, or can you do some suggestions?
Sir, actually, our lab is RoHS testing lab only. So if you test your product, we can test whether it is having any RoHS restricted hazardous substances or not.
Yeah.
So ours is only testing lab, sir.
Oh, you're only testing lab.
Testing lab, and we issue the certificate.
Okay. Thank you, sir.
Thank you.
Any question from audience? I think there is no question.
Okay, provided there is no further question, I would like to thank the speaker of today, Dr. U. Ram Babu from CMET Hyderabad. Sir, thank you so much for spending your time to spare your knowledge along with us. Although you were tested positive, you really did a kind of, it never stopped you at all. You shared your knowledge among us, and also we are so grateful for that. And also we pray for your speedy recovery as well. And we want to see the energetic person back with full-fledged in the science. And also I'd like to thank all the directors from CMET, all 3 centers and DG for providing this platform to have this nice, wonderful session. And also all the participants from various part of country, especially from Maharashtra. And thank you everyone. And with this, I'm closing the session for today. Thank you so much.
Thank you so much.